A very good day to respected panels and fellow innovators. It is a great honor to introduce myself, Dr. Jayshree Andas from University Technology Mara, Perlis, Malaysia, together with my team members to present our innovative product in a VIC 2026. So sit back and enjoy our presentation. Today, we bring to you our product, Blue Lock Mango Char, Trapping Blue, Saving You. Blue, yeah, you hear it correctly. Methylene blue, a blue dye, is a cationic dye which often used in various industries such as textiles and papers. However, due to its huge demand, the market size of methylene blue is anticipated to grow significantly, reaching 5.2% during the year 2025 up to 2032. Despite its numerous applications, methylene blue is regarded as one of the most harmful pollutants due to its toxicity and high solubility in water. Serious risks of methylene blue exposure are hemolytic anemia, fatigue, tissue damage, and photosensitivity. You might be wondering what have triggered us to come up with this innovation. Depletion of non-renewable energy sources had created huge awareness among researchers to move into renewable energy sources such as biomass, specifically agro-waste. And thanks to Malaysia, as it has carved a niche in producing approximately 9,213 metric tons of mangoes in the year 2023. However, almost one-third of a mango fruit appears to be a waste, in which mango kernel accounts nearly 20 to 45% and often discarded in palatable water that severely disrupts the environment and ecosystem. Thus, the main objectives of this work were to synthesize iron-decorated biochar from waste mango kernel for the application as an adsorbent in methylene blue removal. We are proud to say that the greatest novelty of this innovation is the transformation of underutilized waste mango kernel into a sustainable and low-cost adsorbent for efficient methylene blue removal, promoting a circular waste valorization. And by converting agriculture waste into an eco-friendly water treatment solution, this work offers a green, scalable, and economical approach for environmental remediation. In terms of commercialization, this work produces a low-cost and efficient sorbent for dye removal. Let us now sneak into the methodology. Waste mango kernel were collected, cleaned and dried. Later, it was ground and sieved through 500 micrometer mesh and dried at 60 degrees Celsius for 1 day. Then, the powder was heated at 500 degrees Celsius for only 30 minutes, yielding the biochar. To prepare iron-decorated biochar, the prepared biochar was mixed with the iron nitrate in a ratio of 1:2 mass ratio, and then, after the addition of sodium hydroxide, iron mango kernel biochar was filtered, rinsed and dried at 105 degrees Celsius for 24 hours, and the samples were subjected for characterization such as FTIR, SCM and XRD analysis, and later was evaluated for methylene blue removal. For methylene blue removal, 0.1 gram of iron-decorated mango kernel biochar was added in 200 ml of 10 ppm methylene blue, stood at room temperature, and the samples were withdrawn at 10, 20, 30, 40 and 50 minutes and analyzed using UVVs at lambda max 664 nanometer. Removal efficiency was calculated from the absorbance values. Now, let's unveil the exciting results of our innovation. Figure here shows the FTIR and XRD patterns of mango kernel biochar and iron-decorated mango kernel biochar. Following iron impregnation, FTIR spectrum of FA-MKB revealed distinct differences that confirm successful modification. For FA-MKB, the appearance of a weak FeO bond at about 691 was evidence. The shift in C double bond O stretching vibration at 1570 for MKB and 1619 in FA-MKB proved the formation of FeO-C bond. While for XRD analysis, lack of crystalline phases in FA-MKB showed a well dispersion of iron oxide or in nanosized structures. The SEM image of MKB showed a rough and uneven structure with partially formed pores, while for iron-decorated MKB it showed porous network with multiple pore openings, indicating that iron impregnation had successfully activated the network. Proximate analyses estimate four major variables, which are moisture content, ash content, volatile matter, and fixed carbon. And an increase in fixed carbon and ash content in iron NKB showed the effectiveness of this material as an adsorbent. Iron NKB showed effective absorption of methylene blue with the highest removal of 98.26% achieved in only 50 minutes. Thereby, proudly, we can conclude that this innovation was in line with the National Biomass Action Plan 2023-2030 and the National Energy Transition Roadmap, which urged the conversion of waste biomass into wealth. And this work undoubtedly utilized a cheap and available waste mango kernel to sustainable biochar for water remediation. Listed here are some of the publications in progress. And with this, thank you.